my name is Taylor Franklin, and I will be discussing the problem 17 in the book, which states a constant force is applied to an object, causing the object to accelerate at 8.0 meters per second squared. What will the acceleration be if the force is doubled, the object's mass is doubled, the force and mass are both doubled, or the force is doubled and the mass is halved? I know you can't really see that. I'll move the chairs when we get to that problem. However, basically what this problem is trying to entail or trying to teach you is Newton's second law, which is that an object's acceleration is proportional to an object's force and also inversely related to the mass. So what that means is if you look at this equation right here, this is force equals mass times acceleration. We're trying to find acceleration, so I changed it to be acceleration equals force over mass, which makes, the problem easier to solve. So if we look here, the force is doubled. So if we write that out, it's acceleration equals 2 force over mass, okay? So if acceleration is directly proportional to the net force of an object, that means that if something happens to the force, something will also happen to the acceleration. It'll happen the same way. So this would actually double the acceleration as well. So when you double the force, you also double the acceleration. To kind of think of it in a realistic state of mind example, you are pushing on a box, right? You're pushing on a box and you increase the force that you push on that box. That box is going to go so much faster, right? Because you're pushing on that force. It's like with this eraser. I pushed it a little bit. Barely went into it, right? But I pushed it a lot. The force caused the acceleration to also double because I pushed it more, if that makes a little bit of sense. I know it's been a long day, so excuse me if my words are all over the place. But anyways, so directly proportional to each other. So acceleration, when force increases, acceleration increases. When force decreases, acceleration decreases. They're directly proportional to each other. So what if the object's mass is doubled? I can't speak today. What if the object's mass is doubled? You are also going to put it in the same equation, except this time it's on the bottom, right? Well, that just means that basically the acceleration is cut in half. That's because they're inversely proportional to each other. They're inversely related. That means that when mass changes, acceleration also changes in a way. But it doesn't do the same thing as it did with force, where it changes in the same way. If you look at it in this equation, it makes it a little bit more easier to visualize. So if you look here, when you do this math, you'll end up having or cutting in half your acceleration, ultimately. So, yay! Okay, the force and mass are both doubled. So what is that going to look like when the force and mass are both doubled? So let's do acceleration over 2F to M. Basically, the acceleration is going to stay the same. With a lot of examples in our class in physics, you can usually cancel out numbers. 2 over 2 is just going to be canceled out. That just basically, you're just canceling those out. So no matter what, the acceleration is going to stay the same if both are doubled. What about if, let's see, can you see that? The sun is directly in the way. Okay. So what about if the force is doubled and the mass is halved? So that'll kind of look like, I know that kind of looks weird. It's supposed to look weird, okay? So what we can do with this is we can turn this into a more less ugly equation. So we would do we would basically multiply that 2 to go up here so that we can get rid of this ugly fraction. So we would do 2 times over mass. Yay! So now that's going to give us, I don't know if you can see that, that's going to give us 4F over M. All I did in this equation is I moved that 2 to be up here. That way it makes the equation easier to solve. So if you look here, just 2F times 2, which gets you 4F over M. You basically just like, the acceleration will be 4 times greater, because remember, if the force increases, the acceleration also increases the same way. So for this one, where can I write that? So for this one, acceleration will be 4 times greater. So it'll kind of be, or it'll look like this. It'll kind of look like what we did up here. The acceleration is just going to be 4A, because the force was multiplied by 4, the acceleration will also multiply by 4. I know that kind of doesn't make a lot of sense. I hope I explained it as best as I can, but this is the lovely equation right here. Basically what this teaches you is that like the net force and the acceleration change the same way. Mass is what changes it. Mass is what makes it different, okay? So if the mass changes, if the mass is different, then the rest of the equation, it's going to change what the acceleration's endpoint is going to be. Okay, that is all I can think of. You just learned physics. Yay! Okay, bye!